In the past decade, the population of Qatar has increased significantly. In the years leading up to 2011 and 2012, there was a 7.5% population growth rate. Presently, there are no signs of this population growth decreasing since Qatar received the 2022 FIFA World Cup, and the influx of people in Qatar has increased even further. This dramatic growth of the population has increased water consumption. An article published in Gulf Times in 2016 states that there was a 70% rise in Qatar's water utilization leading up to 2013. This inherently goes against Qatar's 2030 vision of a sustainable future, and this project proposes a solution to decrease water consumption.
The first pot is for the manual system and was watered daily using the glass beaker to the right. The moisture sensors are placed next to the roots of both plants. For the automated system, a relay was used as a switch controlling the solenoid valve, which in turn was connected to the virtual bench acting as its power source. When the soil moisture value falls below the minimum threshold of the optimum range for the solenoid valve opens, allowing the water to flow through the plastic tube into the soil. The valve remains closed if the soil moisture value is above the minimum threshold. There is an infrared sensor on the top of the water tank to measure the volume of water consumed by the plant.
To calibrate the IR sensor, a circular piece of foam was placed in the water tank, which initially contained 60 ml of water. The sensor was placed in the center of the tank to ensure that the infrared rays do not bounce off the walls of the container. Once the lab view code was set up, the sensor recorded the voltage corresponding to the amount of water. With each reading, 20 ml of water was added. This is a graph of voltage against volume, which was plotted in Microsoft Excel. It can be seen that as volume increases, the distance between the sensor and the foam decreases, thus increasing the voltage. Linear regression was carried out to find a relationship between voltage from the IR sensor and the volume in the tank, which was later used in the experiment. The experiment has been carried out for 3 weeks. The first week we spent testing the functionality and parameters of our experimental setups. On the 5th day, we encountered a problem. We observed that after a period of time, all sensors went to zero, causing the solenoid valve to open and continuously pump out water. To save the plants, we added a safety measure which stopped the VI when values went to zero, and fixed the error by restarting the system. Once the experiment ran without any problems for 2 more days, we replaced the test pans with 2 new identical plants and repeated the experiment. This is the graph for day 1, which shows change in moisture level percentage over time. As you can see, there's a general decrease in the moisture level. This is the graph for day 2. And this is the graph for day 3. As you can see, both the automated system and manual system were above the threshold value for all 3 days. This graph shows the volume of water added on each day for the 2 plants. From this data, our hypothesis is proved true, as the volume of water added in the automated system is less than that used in the manual.
The aim of this project was to reduce water consumption in one field by optimizing the amount of water used for green spaces and plants. Through the implementation of the automated system, the amount of volume of water that is truly required to water plants and green spaces can be determined. This project takes a firm step towards improving water management and would act as a long-term solution to the issue of increasing global water consumption.